Here's the notes for what we were supposed to accomplish on Friday. What I'd still like to have you work on the worksheet that's due on Tuesday. So here's the notes to help you with that. These are the notes for the 6 trigonometric functions. And what we're really looking at is the basic 3, sine, cosine, and tangent, but we're also going to look at the reciprocals, the reciprocal function to those. Not to be mistaken with the inverse. This is the reciprocal. So as we were talking about with the fractions, reciprocal just means flipping the fraction. So these are our trigonometric ratios. We're going to make a table, and we're going to make this side here say these are the basic 3. All right, and so for our basic 3, we have sine theta, cosine theta, and tangent theta. All right, so for sine, and I know a lot of you write the SOHCAHTOA, so we'll write that SOHCAHTOA. So sine, we have the opposite over the hypotenuse. For the cosine, we have the adjacent over the hypotenuse. And for the tangent, we have opposite over adjacent. All right, so when we're looking at the trig ratios that we're going to add in here to make it a complete 6, we're going to be looking at their reciprocal functions. And these are, beneficial when we start looking later on at trig identities and we have to start solving equations. We need to know what the reciprocal identities are. They're going to help us in solving. Also, you can use reciprocal identities when what the unknown part of your equation is in the denominator. We can actually use it to flip. So here's our reciprocal functions. So this one here is called cosecant. And that one is going to be abbreviated CSC, cosecant. Right? And that's equal to 1 over the sine of theta. So this identity, this reciprocal, is going to be important later on for us. So we're going to go through it now, just in the sense of figuring out the ratios. So 1 over sine of theta means we're just taking the reciprocal of sine. So cosecant is equal to the ratio of the hypotenuse over the opposite side. So we're still doing sides of ratios of the triangle, but we are just flipping them, doing the reciprocal. So for cosine, the reciprocal is secant. And that's abbreviated SEC. And the secant of theta is really 1 over the cosine of theta, but that's just the reciprocal. So that's the hypotenuse over the adjacent. And the last thing we have is the cotangent, and that's the reciprocal of tangent, and we abbreviate that as COT, theta, cotangent theta, is 1 over the tangent of theta. And we're just taking the reciprocal of that, so it's adjacent over opposite. So here's our reciprocal trig functions: cosecant theta, secant theta, and cotangent theta. Obviously, tangent and cotangent sound really good together, so that makes it kind of easy to remember. The sine and cosecant and cosine and secant, they don't really work well. The only kind of hint I can give you to help you start to remember that is that sine doesn't go with the other S. It goes with the C. So cosecant, most people want to put with cosine, but it's actually opposite. So we have sine, cosecant, cosine, secant. All right, so let's look at a problem. Here's a right triangle, and we're going to state all of the 6 trig ratios of beta. So let's actually label this. Let's call this A. We'll call that angle B, and we'll call that angle C. And we're going to label the side. So this is little c, little b, and little a. And let's also throw in beta. And we could call this angle B, but I'm going to use this particular Greek letter. We're going to use beta to find all of our ratios. So the first thing I'm going to do is give us some lengths of sides. So I'm going to say C equals 2 and A equals 1, but I'm not going to give us what B equals, so we need to solve for that. We always need to find all the different sides so that we can use those in the ratio. So let's see, we'll use the Pythagorean theorem for that. So 1 squared plus B squared equals C squared. Let's just write in 2. So the legs squared added together equal the hypotenuse squared. So I have 1 plus B squared equals 4. B squared equals 3. And then if I take the square root of each side, B equals plus or minus square root of 3. But because we're dealing with a triangle that has all real numbers that are positive, we're going to go ahead and just say that B equals the square root of 3. We're not going to worry about that negative sign. So B equals the square root of 3. So let's go ahead and write all of our ratios. So the first thing we have is we have the sine. Oh, we're not doing theta. We have the sine of beta. Sine of beta. Well, we know our sine is opposite over hypotenuse. So we have the square root of 3 over 2. And that one's done. We don't have to worry about simplifying this anymore. The next thing we have is the cosine of beta. Cosine is adjacent over hypotenuse, so 1/2. And then we have the tangent of beta, and that would be opposite over adjacent. So the square root of 3 over 1. And we can just write the square root of 3. So here's our basic 3, and we can get away with knowing that, but we're also going to be studying these reciprocal functions. So the reciprocal of sine we have is cosecant. And I'm not going to worry too much about whether it's, hypotenuse over opposite. I'm not going to really worry about that. I'm just going to know that it's the reciprocal of sine. So when I am going to put this, I'm just going to flip these. 2 over the square root of 3. It's the reciprocal. But now this is where we had to practice simplifying, and we're just going to make this now be multiplied by radical 3 over radical 3. So 2 square root of 3 over 3. Here's our cosecant of beta. Our secant of beta is going to be the reciprocal, so it's just a 2. And then for tangent, we have the cotangent of beta, and that'd be equal to 1 over the square root of 3. And we can't have that, so we multiply by the square root of 3. So we have the square root of 3 over 3. So here's finding our 6 trig functions. If we know how to find the originals, then we can easily just find the reciprocal functions over here.